Good evening, Team A1. Today we're going to be learning about classifying numbers. So our I can statement is I can identify rational versus irrational numbers. That's what we're going to be concentrating on today. This first step is to identify that all numbers are real numbers. So you can see at the top of your screen right now, you can see that the real numbers is already listed up there. So for you guys, underneath your PowerPoint, you're going to see these words and we're going to put them in the right place. Now, I know you can't move it on your PowerPoint, but you can go ahead and write and take notes as we go along. You'll notice underneath I also have typed the words, and so we have some definitions that you're going to need to be doing. So if you want to stop the video right now and write those down, you can, or we will go over those one at a time. So at the top of your screen, you're going to see real numbers. And yes, I just had to get on a chair to get up there. It's the vertically challenged part. So today we're going to break these bubbles into categories. So there are two categories of numbers. There are irrational. There are irrational. Notice this bubble over there all by itself. So it looks like if a number is irrational, then that's it. It's just irrational and it doesn't fall into any other category. Irrational is on the left, and then you can see rational is on the right. So obviously rational is going to be a larger group of numbers. So let's talk about what those are. So to begin with, irrational numbers cannot be written as a fraction. Irrational numbers cannot be written as a fraction. Let's take that. Let's think about that. The most popular irrational number that you probably already know about is pi. Pi is 3.14 blah, 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 blah. It goes on and on forever. It never stops. It never repeats. It never terminates. Stop and terminate are the same thing. So an irrational number would be an example like pi. I couldn't write that as a fraction. So it cannot be written as a fraction. Let's think about some other examples of irrational numbers. Just kind of as a slang term, I would call irrational numbers cray-cray. Yep, that's right. They're crazy. Just sort of like an irrational person. You can't have a conversation with them. They're not logical. You kind of just want to walk away. That's what we know about irrational numbers. They're kind of crazy as well. So what are some examples of irrational numbers? Well, if it is a square root, a perfect square is always going to be an integer. It's going to be a whole number. So if we talk about square roots, we're going to think about, okay, what's the square root of 1? Well, that's 1. What's the square root of 4? That's 2. What's the square root of 9? Well, that's 3. So all of those in between the square root of 1. So for example, the square root of 2, the square root of 3. If I were to put that in my calculator, it would come out, square root of 2 would be 1 point blah, 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 blah. 3 would be the same thing, 1 point blah, 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 closer to 2, which is the square root of 4. So what I'm telling you then is any of those numbers in between perfect squares, those are also irrational automatically. So you can't think, okay, well, if it's a square root, it's automatically irrational, because there's nothing irrational about the square root of 1 or the square root of 4 or the square root of 9. But the square root of 2, the square root of 3, we know that that's going to go on forever and ever and never stop. So what I want you to write, I know you have a lot of room on your PowerPoint somewhere, so go ahead and write. Make sure you've written the definition of irrational numbers. It cannot be written as a fraction. And another, it's crazy. And then also, it is a non-perfect square. So say it's a non-perfect square, that would fall into the category of irrational. Notice it's out there all by its lonesome. So if it's irrational, it's irrational. The number doesn't fall into any other category. Moving on to rational. Well, if irrational numbers cannot be written as a fraction, guess what? That is a definition of rational. It can be written as a fraction. So make sure that you have written down that it can be written as a fraction. That's the big umbrella. Rational numbers can be written as a fraction. So moving on, the next category is going to be, guess what? Is it going to be integers, natural numbers, or whole numbers? Well, I would say that that would have to be, wait for it, right? Integers. And the definition kind of tells us why it's next. Having a hard time moving this. Okay, well, there, perseverance. Moving that. I want to move this. Good, now we're there. Integer, so that's going to be the next bubble. As far as the definition of integer is concerned, integers are whole numbers and their opposites. So when I think of integers in my brain, I say, well, I know it's the number 0. Make sure that you include the number 0. But it's whole numbers, which whole numbers itself includes the number 0. We'll get there in just a minute. So integers are whole numbers and their opposites. So my brain says 1, -1, 2, -2, 3, -3, etc. Notice that I did not say, non-examples kind of are helpful too, not something like 2.1. I wouldn't see that on a number line. So that's kind of a good way to think of integers. It's going to be those numbers that you would actually, if you were going to create it on a number line, you would write those numbers. Those are all considered integers. So I would say whole numbers and their opposites. In my brain, when I think integers, I think 0, 1, -1, 2, -2, 100, -100. You get the point. So the next category then, we have whole numbers and natural numbers. There's only one tiny difference between whole numbers and natural numbers. Whole numbers are counting numbers plus 0. We kind of just talked about that. So whole numbers are counting numbers plus the number 0. So when you learn to count, your parents taught you to count 1, 2, 3, 4, 5. But did you also know that 0 was part of that category? Here we go, whole numbers. It's right there in the purple. So the only difference between whole numbers and natural numbers are just the counting numbers. So in other words, natural numbers is not the number 0. So you might want to add that to your definitions. Make sure you've included those. So our last one then would be natural numbers. So all numbers are real. So that's the question I would ask myself when you categorize a number. Is it real? Or yes, if it exists, it's real. So all the numbers that we deal with in Algebra 1 are real numbers. Then we compare irrational to rational. If a number is irrational, it's only irrational. It's never going to be an irrational integer or an irrational natural number. No, because look, natural numbers are sitting over there all by themselves. Rational numbers, then, the categories break down. Rational numbers can be written as a fraction. That's the big piece of the puzzle, the big thing to remember, the big umbrella. And then integers, obviously integers are going to be a bigger category of numbers because it's going to be the whole numbers and their opposites. So we're talking about positive numbers and negative numbers. Whole numbers are 0 and all the positive counting numbers. And then natural numbers are just the counting numbers, not including 0. So let's take a look at a couple of examples. We have the numbers listed at the bottom, and we're going to put them into a category. So I'm going to kind of talk you through that, and you can just list them in the bubble that you see. Let me switch this to a larger screen. I need to click it. There we go. All right, so now we go, and we're going to put these into a category. So here's my thought process. Remember, the big category is it real? All of these numbers are real. So when you're listing this out, you always want to say that it's real. That's a good place to start. Then you say, is it rational or irrational? Well, 1/4, can it be written as a fraction? Yes, it can. So if it can be written as a fraction, it is a rational number. But is it an integer? No, because I don't count by 1/4. In order for it to be an integer, it would have to be 1, -1, 2, -2. So on and so forth, and including the number 0. We already said pi, that's crazy. It cannot be written as a fraction. 1/2, well, that's written as a fraction. I guess that makes it rational. 3/4, yep, that's just going to be rational. So anytime it's just a fraction, that automatically puts it right into the rational category. The square root of 9. Well, before you just kind of chalk it up to, oh, it's a square root, it must be irrational. No, it's not, because the square root of 9 actually is the value 3. Yep, that's right. So the square root of 9 is 3. So 3 would fall into, obviously it's rational. There's nothing crazy about that. Is 3 an integer? Yes, it's 3 or negative 3. Is it a whole number? Absolutely, it would be a whole number, and it would be a natural number. So by putting it in natural number, we're saying that it falls, so the square root of 9 falls into all of those categories: natural, whole, integer, and rational. The only difference between whole and natural is the number, yep, 0. The square root of 16 would be exactly the same. The square root of 16 is 4, so square root of 4, or I'm sorry, the square root of 16 is 4. That's rational. It can be written as a fraction. If you're thinking, how can it be written as a fraction? Well, any number can be written as a fraction. The square root of 9 is really 3. If I put it over 1, it's still a fraction. It's just writing it as a fraction, but we haven't changed the value. The square root of 16 is 4. Well, 4 over 1, that is a fraction. So remember, go back to that idea of, can it be written as a fraction? But then obviously it's a integer, it's a whole number, and it's a natural number. Unlike the square root of 5. So the square root of 5 is a non-perfect square. We know that non-perfect squares go into the irrational category. The number 12, well, if anytime it's a whole number, you guys, and it's not 0, then it's going to fall into the natural number category. 0.67, we haven't really talked about decimals, so let's make sure that we touch on that here. 0.67, could I write 0.67 as a fraction? Because right now I'm trying to decide. It's real, of course it's real. Can it be written as a fraction? Well, sure it can. Here's 0.67. 0.67 is equal to 67 hundredths. Yep, that's pretty much a fraction. So let's think about that for a minute. Is it rational? Yes, there's nothing crazy about it. But is it an integer? No, I wouldn't put that on a number line. It would just fall into the rational number category. And that's it, just up there in the blue bubble. What about 2.33333? We can see that that is going to repeat forever. Even though I don't see a bar, I know that it repeats. So the question is it crazy? No, that we can make sense about that. We know that 3 as a repeating decimal actually changes into 1/3. You guys have had enough experience with numbers that you know that that 1/3 as a decimal is 0.3 repeating. So that's what we have here. So that's going to just go into the rational number category. It's not irrational, because an irrational number never terminates and never repeats, and this one does. So it's not so crazy. And that's exactly the same. It doesn't matter that it's negative. The same thing applies for negative 3.222. It's repeating. We could write that as a decimal. We could change a decimal into a fraction. It would be negative 3 2/9. That's what the equivalent would be. Negative 71. Let's think about that. Is it crazy? No, nothing crazy about that. I could stick it over 1, and that makes it a fraction. That makes it rational. Is it an integer? Sure it is. 71 or negative 71 falls into the integer category, but that's where it stops, because whole number would have to be positive. Whole numbers have to be positive only. That's the only thing we're looking at. And then we have this lovely number 0. Where's 0 going to go? Well, remember, the only difference between whole numbers and natural numbers is the number 0. So whole number has to go in 0. I'm sorry, the 0 has to go in the whole number category. It is not considered a natural number, because natural numbers are counting numbers. That's going to do it for classifying numbers today. I hope you enjoyed the lesson.